Okay, so thank you everyone for making it to Friday's meeting. I know not all of you guys could be here because there's things going on with AP and office hours today, so don't worry about it. Today I'm just going to go things over very quickly because tomorrow, Saturday's meeting, which is probably going to be at 7 p.m., that's going to be the main bulk of our meeting. So if you guys haven't known by now, I'll just make an official announcement here. We're going to move on to 3D modeling revisions, and it's going to be pretty fast paced, as in we're going to keep on going. So if you guys haven't known, let me just kind of update you on things. I've been contacting with Dr. Kova, but unfortunately she's on maternity leave. So maybe when she comes to campus after COVID is over, tell her congratulations. But as for now, she is on maternity leave, so it's a little bit hard for her to help us. But although she's gone for now for a couple 1 or 2 months, a good news is that Leader's Rehab Robots is gonna help us a lot from now on. They're gonna be since Dr. Kova is the one that helped us with the designing and functions, Leader's Rehab Robots is gonna be the one directly helping us manufacture and 3D model and create blueprints and all that. So just letting you know, some kind of recent news. Also, one thing, I did contact Leaders Rehab Robots about mechanics, internals, wirings, motors. Okay, so here's my conclusion. We've done a lot of things as a club. We definitely did a lot, way more than I was thinking of, like with the students participating and us actually creating the models and everything. But one thing we can't do is coming up with specific model numbers, motor types, because if you guys know, America has a standard for medical robots and medical devices and specific motor restrictions, specific year restrictions, certain safety measures, things like that. It's a little bit hard for us to do it because then we just have to go through like a bunch of laws and policies, and then it'll just be hectic. So if you're wondering what our mentors are going to do for us, that's the part they're going to do. Like going over the specific, like what motors we need. Oh, what I should say safety measures are like necessary, essential, and going over the general construction of the device. So just a little news for everyone. Okay, so with that said, let's go over our bulk of the meeting. Now, you don't have to particularly pay too much attention to everything I'm saying. As I said, today's going to be a brief overview and just kind of like a recording so that people who are going to look at this later and tomorrow kind of get a gist of idea. Because tomorrow's meeting is going to be pretty activity focused. Like tomorrow, we're just going to keep on working, revisioning, editing, things like that. So if you guys don't know, I've submitted the form or the annotated blueprint to our mentor. He already reviewed it. Leaders Rehab Robots gave us some revisions. And what I did was I asked them to download Autodesk Inventor, and they were able to go through all our models too. Now, unfortunately, not every one of you guys' models could be used because I made most of you guys turn in 2 models instead of 1. So, one of them had to be picked so that other students can get their parts there as well. So just know that. Alrighty. So important due dates. Just a quick notice. You're going to have to finish your 3D modeling revisions by April 28th. Now, I know this is pretty sudden and there's only like a week, but honestly, we don't have any other options. Our mentors he's very well, let's just say he's really pushing us because for them, we don't want to cause them any more work than they have to do, and we don't want to cause them unnecessary concerns with manufacturing. So by April 28th, we need a complete 3D model. The robotics company has a general idea of what we're going to do, and they're already prepped for that, but we need to give them any significant changes with our model by the 28th, or else they're going to have a difficult time manufacturing it. We don't want to do that. So just know that for this week and next week, it's crunch time. So please try to get things on time. And as I said, I'm going to make it due 28th, but we need And this is a 100% need to submit our complete 3D model to our mentor by April 30th. So just know that. It's a complete necessity. Okay, so here's a part list. Now, as I said, not all of you guys' parts are going to be used because some of you guys I assigned 2 parts and some of you guys I assigned 1. So these are just things with it. And for people who didn't get their device chosen, don't worry. You're going to be tasked with revisions and tiny little details and additional parts that need to be modeled. So no worries there. So here's just a quick parts list. Wrist 1 is going to be handled by Lyndon. Oops. Oh, looks like I... All right. So wrist 1 is going to be handled by Lyndon. Wrist 2 is going to be Junso. Wrist 3 is going to be Cyrus. Wrist 4 is Michael. I'm going to take F1 only because our mentor gave us very specific feedbacks about it. I'm going to go over that later in this meeting, but just know that for F1, a lot of things happen. And F3 is going to be Ethan. And you might be saying, well, where's F2? Well, that's also one of the things I'm going to address later in the meeting, but our mentor said get rid of it, so we're going to get rid of it. Okay, so now, just a quick reminder, I'm going to go over a lot of details, but you don't have to worry about actual revisions. Right now, what you have to worry about is mentor feedback. That's what I'm going to go over today. Tomorrow is going to be the actual 3D modeling revision. So just take that into mind when you're listening. Okay, so wrist 1. Now, Lyndon, you're in charge of wrist 1. There's quite a lot of things to do. One of the things our mentors specified along with Dr. Kova was having a very root, I guess, or a constructive base where the device won't move. So if you see this picture, this is the bottom side. We're going to put in these pads over here so that the device doesn't slip, because when the patient have this thing on his table, his name's Mr. Daniel, if Mr. Daniel's trying to operate this device and it slips off and it falls to the ground while his hand is still on it, that's a huge safety concern. So we're going to put these pressure pads there so that the device stays firm. So that's that. All you have to do is just draw a certain, just make little circles on the sides, and all you have to do is just extrude it by like 0.1 or something like that. Now, you're also going to have to take off some weight. Leaders Rehab Robots, when they were reviewing our 3D models, they specifically said that in the real world of engineering, which was something we're trying to get into, we're going to have to be a little bit more efficient than using an entire sheet metal, because think about it. If we're going to give this to Mr. Daniel or any other patient who's going to use it in their house, it's probably best that it isn't so heavy to the point where they can't use it. So, Lyndon, all you have to do is just cut these corners out. And of course, I'm going to go over this in specific tomorrow, but primarily listen to the feedback, like being more efficient and making sure to put these safety measures, things like that. Just keep that in mind. So if you're wondering what this is, it's just going to be holes cut in, kind of like skeletonized, basically, the structure. Now, these one cost me quite a lot of time to CAD, but what these are stoppers. Now, this was a specific request from one of our other doctors who specifically wanted to say that some patients, their hand wants to be locked in at a place. Like right now, our device can move the wrist like that, but some doctors want it where it can go to this position and stand there, like stay there for like 30 seconds or like maybe a minute, how long the patient needs. So that's kind of like a stopping mechanism. And when I contacted Leaders Rehab Robots, they said they're going to come up with like a little dial, I guess, as to say, that goes with regulations. So you don't have to worry about the mechanism that puts it into place, but you will have to CAD little holes outside. So as I showed you before, this is going to be the final model / revision for wrist 1. Do any of you guys have any questions with wrist 1? Okay. Now for wrist 2, this is Junso. First of all, one of our mentors said that we don't need all that extra space. So we're going to have to reduce it by 1 inch. So the space between the top, or I should say the bottom of the top, and the actual bottom is only going to be 1 inch. And of course, that's also going to have to be 1 inches as well because it's going to have to fit perfectly. Wrist 3, you just have to reduce it by 1 inches. Again, with the whole being efficient, our mentors don't need all that space, so we're just going to shift it up by 1 inches. No big deal. Just get it done quickly. Wrist 4, Michael. We might have to get rid of the whole adjustable settings because our mentor said that's too much space that we need.
Too much space?
Yeah. Like if we make it adjustable, it'll be too wide and it's going to be hard for transportation. So you just have to cut off the little parts there.
Why is it there?
Yeah, it's like
So,
no need.
oh, I also put specific measurements for how it should be.
Okay.
You see those on the the annotated blueprint. I put measurements and everything.
Yeah. So right now the dimensions for the overall plate is fine, but then we do have to remove the adjustable factor because, it's just kind of like a balance between feature and weight. They don't need all that space in the first place, and they don't really want to make it so that the patients have to fiddle with it, because if the patient is unable to secure it properly, then it might be a problem, and we can't always expect them to adjust it properly. So
should we just have a big foam pad there to keep it in?
Yeah, basically.
Okay, that makes sense.
Yeah, our mentors actually proposed that we keep what do they call it? Friction pad or something like that. The one where it's made out of rubber. They're gonna coat the entire thing with it. Each part where it makes contact with the arm, they're gonna coat it entirely in this black layer called static. I don't know. It's just like
It's
a
like
rubbery,
rubber, right?
Yeah.
Yeah. It's like the stuff that you find on workout benches.
Yeah, exactly. Alrighty. So F1. Now, okay, I'll let you guys know what's happening with F1. F1 has always been a little bit of a trouble because, again, that's the part where Dr. Kova gave us a suggestion, and she was kind of focused on F1 as well, because Dr. Kova was thinking, well, if a patient's hand is shut closed, how is he going to apply the device? How is he going to put his hand in it that fits it in? So what I did was, well, I'm going to have a pointy shape. Now, this is just some liquid container, but basically, if a patient's hand is shut, he can, because there's a wedge over here, patient's hand can basically slide right in like that. You guys kind of get what I'm trying to say? Because, and here's just a canned soda. Patient really can't, if he can't open his hand, then he can't grasp onto it. He needs to open it. So what we're going to do is we're going to have a little rounded edge that acts as a wedge for the actual fingers to open. So just kind of letting you know. And of course, we can't make it too bulky. So this is a more comfortable shape that I thought of, where you can just grab onto it and it'll be a little bit easier to use. And oh yeah. So apparently there's a specific part in your wrist that doesn't exactly work. It's one of the complicated parts of our wrists, especially because our wrist, it's a very complicated anatomical structure. This is one of the things Dr. Kova recommended, where it needs to be a little bit slanted because it's a little bit easier for them to grasp it. It's a little bit hard to explain this because I don't have the exact medical knowledge to let you know which bone or which joint is causing this. But this was just a recommendation from a, medical professional, as in, it's a little bit more comfortable to patients to have it a little bit slanted. So this little slant is basically accounting for that. We're going to drill a hole in there. There's going to be a rod, and it's just going to be a little bit of slanted surface. And with F1, I kind of got rid of the pin because we didn't have enough space. I don't know if you guys know this, but that's 0.5 inches. If you have your ruler with you, it's That's actually very short. And we don't want our mentors to drill in holes that are like like surgically small, because then it's going to halt production. And we don't, excuse me, exactly want that. So just know that we're going to have to take into account actual real life variables, because here's the thing. Again, like I said, our mentor is actually going to help us build this thing. It's actually going to be 100% built within a couple of months, and a patient who volunteered and a doctor who volunteered may actually use it or try it once or twice. Back then, when we were 3D modeling, we could make all sorts of holes. We could do all sorts of measurements. We could do all sorts of things. But right now, we need to account for that realistic structure of our 3D models, especially like this hole over here. We could make an entire hole and a pin and make it 0.1 inches. But if you guys have a ruler with you, 0.1 inches is like not even the size of my fingernail. It's very, very small. That's like a surgically small measurement. So we're going to have to remove things like that. So obviously, if you think of 0.5 inches, that's like around the size of your pinky or index finger, I should say. So, if you're noticing all these changes and you're wondering why we're doing them, it's not especially because something's wrong with it. It's just that now that we need to account for real world physics and compatibility, we need to make some changes so that our mentors don't have too hard of a time helping us build this. So this is what it's going to look like. I know it looks very weird, but essentially what I just said, patients are going to have to use the wedge as like a way to open it, and they're going to grasp onto it. Now, this can be so malleable, this design. It really doesn't matter at the end of the day, because here's the thing. Let's say we're unsatisfied with this design. Well, all you can do is just 3D print or maybe get some plastic and make this a little bit thicker than it has to. Or you could try foam padding or silicone padding. It's really simple. So for F1, I'm going to assign someone to specifically edit it. So, whoever is going to tackle on that challenge, please don't think you have to do everything precisely, especially F1. It's such a volatile piece that can change it. So don't worry too much about that. Now, for F3, before I go to F3, I got to make a quick announcement. F2, it was scrapped. Our mentors didn't like it at all. They were saying it's a little too complicated, and then the mentors were kind of like saying they're going to take care of the safety mechanisms. They're going to do that for us, so don't worry too much about it. That's what they're trying to say. Like, they don't want high school kids to like focus on what's safe and what's not safe, because at the end of the day, we really can't access we really don't have an educational basis on medical safety and things like that. So they said, don't worry about it. We got that covered. So for F2, we're not going to do it because it was strictly a piece meant on actually, keeping the hand from falling, but they have a different idea. They're thinking of putting like pads just connected to F1. So like they'll probably connect something to this base where it's just gonna like kind of like a basket almost, where the basket hold the hands in. So that's why F2 had to be scrapped, and it's a pretty good thing, because as students, safety mechanisms and little minute details like that, it's a little bit hard for us to account for. So, that's good. Now F3, you're going to have to take this triangle out. And one key thing in Autodesk Inventor is that when you want to take something out, you could draw like a huge shape and just extract it in a negative direction. So like, let's say you wanted to take out, let's say for wrist 4, there used to be a complicated structure connected to it. But what I did was I just drew a giant square and extracted everything beyond. So I'll go over this more precisely tomorrow, but what I'm trying to say is these edits really aren't that hard. So, some of these edits are going to be hard, like Lyndon's. Your wrist 1 is going to be a big deal. Junso is going to help you with it, but for everyone else, it should be a little bit easy. So you're going to draw that little triangle and you're going to extract it. You're going to cut it basically like that. And you're just going to have to extract a semicircle that's 0.5 inches long. Now, here's what the complete assembly looks like. Now, this is a very template model. I rushed this last night, so I don't want you to guys think that, oh, everything's done, because it definitely is not. These are very basic models, and last night when I was doing them, the constraints weren't even working. So like the 3D model just wasn't even moving at all. So basically that's a sign of rushing. Like whenever you rush a 3D model, it's not going to fit perfectly, and it's going to give you a lot of errors because computers are very specific. So we have a target model, but don't think that we're done because we have this rough structure. This is like a very, very, very rough structure. Like if you see the edges over here, I didn't even fillet, and it's really rough basically. So know that there is help if you want to like look at this to get help. It is there, but please don't think it as we're done. That's how it looks like from the back. The patients are going to put their hand in from here, grasp onto that, and that thing's going to open, and that's going to facilitate motion. It's just like a quick drawing from the front. I didn't put the left cap here just to kind of show you guys how the device actually looks like. Remember when I said it had to be tilted at an angle? If you see this black part over here, that's what it is. You're not just grabbing onto it. It's going to be a little bit tilted, or it's going to be a little bit tilted like that, so that patients can actually just grab onto it, and it's going to spread a little bit more wider. Because one of the concerns Dr. Kim had was that it might not open up fully, and that's why he suggested the little angle of rotation when it's actually rotating. Alrighty, so just a quick notice. File submissions. You're going to have to click on this link, and you're going to have to turn in your revised models at a folder called Please Upload Revised Files. Pretty self-explanatory. Now, if you're stuck or need help, you can find the finished models at expected models for reference only. So let me show you what I mean. Oops. Okay. Okay. So if you look at my folders here, blank sheet files, ignore that. We're already done with that. Expected models. This is where all the files are at. That's the complete figure. Like everything's done over here. If you need help for reference only, you can open up one of these files and see what it should be, but don't just like copy and paste one of these files and turn them in. Old files, just ignore that. That's everything's done with them. And this is where you submit your files. Please upload revised files. So there's that. You can, like right now today, you can edit your 3D models if you're confident enough. But for people who are wondering like the specifics of editing each part, I know you guys are having difficulty. Like, how do I do all this? Like, is there a specific mechanism?
I've got to go, man.
Alrighty, take care. But yeah, if you guys are wondering like the specifics on how to edit all these parts, that's what we're going to tackle tomorrow. Now, before you guys go, here's an actual model. I hope you guys can see my screen. Yeah, this is basically the end goal. But you see how all of these structures are like kind of crude, like there isn't a hole there. Like these aren't properly filleted, and that's definitely not nice looking. And probably these like, little points like these, they shouldn't be there, should be rounded out. And design details over here, like how it's not matching and all, little things like that, and how there aren't like any screw holes. That's going to be what you guys are going to be focusing on. You guys are going to do the general requirements. It's going to take you like 5 minutes to CAD, but it's going to take you like the primary part is going to be actually editing, your 3D models. So with that said, you guys are free to go. Tomorrow, 7 p.m., just know that. Junso, are you available tomorrow at 7?
For school?
No, tomorrow.
Yeah, tomorrow's. Before school or after school? I mean, not school, sorry. Morning or afternoon?
Afternoon.
Yeah, I am.
Okay. So I know you missed this meeting, but it's fine. I'm gonna go into everything into specifics tomorrow, so don't worry too much about it. Just try to make it into tomorrow's meeting at 7 p.m., okay? Alrighty. You guys are all free to go. Thank you for coming.